Hey guys. So if you've been paying attention to, uh, I don't know, common trends lately, you'll know that Wordle has become a big hit, and a lot of people have been talking about it. A lot of people have been playing it. Seems like a pretty fun game. I saw a video by Three Brown One Blue, I believe, and him making a bot to automatically solve it. I thought that was really cool. It was a really fun video, but this is the first time that I've seen Wordle, and I thought it looked like a really fun project to build an AutoHotKey. A really basic one too. You can do it with just simple GDI, GDIP, and I woke up this morning and I put one together really quick, and I thought I would share it with you guys. So I'll put the source in the description so you can go check it out and tinker with it, or do whatever you want with that. That's fine. But I thought I'd go over it here in the video as well to explain what certain things do. Also, keep in mind that I am just a hobbyist when it comes to AutoHotKey, so this may not be the best way to do things, but this is how I did it, and keep that in mind. There's improvements to be made for sure, definitely. But the first thing I do is I have two classes. One is the game class, which handles almost everything, and then the other one is the block class. And the when I say blocks, what I mean is like these right here, and then these. So I have a class that handles both of these, guest blocks and keyboard blocks. It's in the same class though, so I just specify a block type, and that makes the tiny changes necessary to make them work. But we'll get back to that in just a second. Some simple Windows messages: erase backgrounds. If you have a function here for this and it returns false, I don't know if that's important, but doing that will prevent it from being erased when it's dragged off screen. So that's pretty important. Start drag, end drag. Basically, there's no reason to draw the window when you're dragging it. It just makes it a little bit smoother. We track the left clicks so that we know when you've clicked a button, as well as mouse move, so that we can keep track of the X and Y position of the mouse. You could use mouse get position. I don't know. They're both similar, pros and cons to each. And then we have an update with a 10 millisecond interval, although realistically it's more like 15 milliseconds, which is fine. And then we just draw from the class from there. So we have some functions here. Get random word, really simple. Provided a list of words in an array, it will choose a random one. Generate word lists. Now this one I do use the lists that Three Brown One Blue uses in his GitHub, since I didn't really know where else to get them, and he already did all the work of doing it anyway. So it'll just automatically download it into a file for you, and then it's pretty simple. It just sets it up with some error checking, because if the GitHub servers are down, it won't actually download the list, so it'll let you know here. Otherwise, pretty simple function. The set letter list. This creates an array of all the letters, as well as two special cases here, which is, if you look here, there's an enter and a delete button here, and I have them set up just for convenience sake here. It basically means the letter list determines the color. So for instance here, the Y was wrong, so it's grayed out. The R was correct, so it's green. So enter and delete should always be this color. So I just set them here. Key valid is that color. Random's random. Everything else is easy there. So now the game class itself, I have it scaled off of height. I'll go ahead and run it really quick actually. So you can see here, this is what it will look like no matter what height you specify. So I'll go to the class here, and I'll put in a height of like 600, and I'll reload that. And as you can see, it scales, and it's 600. So if I try to put that in, for instance, it's not a valid word. But if we put in the weary, of course, that is a valid word. And everything updates correctly. I'll increase this back up so you can see. And yeah, scales. So that's what most of this is for. Most of this stuff here. Word size 5. That's just the length of the words. Tries is the columns. So you have 6 columns, 6 tries. If you hit 7, you lose. We generate the words into this array. So this array will have the allowed words, the possible words, and the size of both of them. The secret word, of course, is what you're trying to guess. In my program, I have a variable that allows you to see it for debugging purposes. So if I were to type in this, of course, it would tell me it's the correct word. The guess is what you're currently guessing. So right now it's nothing. Let me reload that actually. So right now it's nothing. If I type in W, my guess is now W, and so on and so forth. Guess index is the row that you are guessing on. So I'm guessing on the first row, so my index is 1. Mouse holds the positions. Color just holds colors. They're set down here. I took these right off the website from Wordle by inspecting the element. So if you just inspect an element and you look down here and you click this box, it will tell you what the color is. And I just borrowed that. Pretty simple. Done. I added this in. If you win or lose, it'll prevent input from happening. So if I type in the answer, I can no longer click these. They don't do anything since you already won. Show secret. That's the thing that allows me to see the word. So here's setting up the GUI. If you put in +H window, the handle to the window will be stored in this variable. Very convenient. And then we'll get a handle to the GUI. Then we'll create a compatible DC that we will use as a buffer, and we will draw onto the buffer, and then we will bit block transfer that onto the window so that there's no flickering and it'll be very smooth. So here I'm defining the guess blocks and the keyboard blocks into an array, so I can loop through them and check. It's a 2D array. Actually, yeah, I think so. Yeah, I think that's what it would be called. So it has well, you can see right here. So it has the tries, which would be 6. It'll have 6 columns of 5 rows each. And I just do some really simple math here to make sure that it's centered. So I take so where we start drawing the blocks will be right on this corner right here. And to get that information, I take the width of the client divided by 2, I minus the block size times how many blocks there are, and then obviously I take the spaces in between as well, and that'll be the word size -1. So there's 4 spaces here. Take all that into consideration, and you have your position. Super easy. Not much else to explain here. It's pretty self-explanatory. I add the block class here into an array, specifying the parent as the first parameter, XY, size, and the block type. And I do the same thing for keyboard, except this one's a little bit different because we want to copy this layout from the website here where it has like a bigger one on top, shorter in the middle, and then the same on the bottom. So I have an array here, like a string array, and it'll split these into columns and rows. And a little bit of math, but nothing special going on there. So here's the guess, where we do the check guess. And we take the guess word and the secret word, we split the letters into an array, and we loop through the array, checking both. So if they are the same, then we will set the block at that position. Say it's the F. So the F is the same. So we'll set it to be guess corrects, which sets color to green. And it sets the letter itself to be F. And then we'll take the letter list and we'll say the letter F is correct. So the keyboard knows to highlight this as green. If the letter is in the word but not in the right spot, then it'll do all the same thing, except it'll set the color to yellow, which is contains. However, for the keyboard, the letter list, it will not do that if it's already set as green. So imagine let's just type in something randomly here. Okay, so this R, if we typed in another word that had R in it, like I don't know. We can do reals. Now the R doesn't become yellow, it stays green because it was already found to be green in the first place. And then if neither of that is true, then it's wrong. So all of these letters will now be marked as wrong, and you can ignore them. So after we've guessed, we need to loop through the words and set them to 1. So now they are set, they lose their border, they get their color, and you can't mess with them anymore. If the secret word equals what we're guessing, then we're done, no more input, and you get the message. Otherwise, if your guess index is larger than the amount of tries you get, then you're also done and you lose. Just some simple functions for adding and removing the letters on the current guessing row. A reset here, so it resets all of the blocks to default. It gets a new word and it resets the letter list so that all of these are now back to this light gray because they're usable. And then we have the drawing function where actually I didn't mean to have that in there because in the function mouse move updates this. So yeah, didn't mean to have that in there. That wasn't doing anything. Or it was, but it shouldn't have been. So this is filling the backgrounds right here. And then this is the text drawing on the top. We will. So I added this this clicked part right here because technically, if you clicked a button during the middle of a draw, it could make it so that the click doesn't go through. I don't know how likely that would be, but just in case, I added this here. And then we loop through the guessing blocks and the keyword blocks, and we draw them. And then we bit block transfer it to the GUI window. So everything you see here that's being drawn is being drawn on the buffer, and then it's being swapped over to the GUI window. Here's the block class, which just does the drawing for both of them. It's pretty easy. We have in here for if block type equals keyboard, we'll check to see if the mouse is hovering over it, which is this function right here. And if it is, we will highlight it and put a little border around it so that you can see what you're hovering over. And then also, if we click to the mouse, then go to this .click function, which checks the length of the currently guessed word, and only because it's used so many times here, it's just easier. So if we click delete, then we'll check the length, and if there is something, we'll remove it. If it's enter, and we have 5, although actually this needs to be this parent word size. So now if the length equals the word size, then check the guess. Else, if it's smaller than 5, then just add the letter. And then here's the set letter for this actual block. Pretty easy. And then that's pretty much it. And the game works fine. So I'm going to try and get a different word than that because that's... Okay, so happy, here's one. So let's say we started with like crane. Right, we know there's an A, not an E. I like frogs. We'll do frogs again. I don't know. So frog, completely wrong. Okay. I don't even know. Let's do putty. Okay, so no, the Y is right. P has a P and an A. I don't even know. I'm not really good at this game. So let's just say it's... Is fatty a word? Okay, fatty's a word. Okay, then I'd be like, oh man, you know what? It's probably, I bet it's happy. I bet that makes sense. It is happy. Oh my god, I got it. It's amazing. So then there you go. And then press F1. It'll start a new one. And we know the word is joust. And then, yeah, it's that easy. And then obviously if you wanted to not be a cheater, you would turn this to off. And then now you don't know what the word is. And there you go. That's pretty much it. It's a pretty easy game. Super easy to program. And hopefully you guys will find some I don't know, something useful with this video and the source code. So yeah, have fun with it and let me know if there's anything you need to know about it. But I think I went over most of it. So yeah, catch you guys later.